Good morning, Year 4, and welcome to Friday's maths lesson on fractions. Before we go into today's learning, I'm just going to go over the challenge question from yesterday's learning, because for those of you who did go onto the challenge, you will know that I waffled on a bit and I didn't really give a very good answer. So I'm going to go over it again and hopefully explain it a bit better today. All right. So if you didn't do the challenge, just say on anyway because it will be useful for you as well. So the question was, explain how a fraction wall shows equivalent fractions. So we looked at a fraction wall yesterday. It was the big rainbow one. It's the same as this, okay? It's still a fraction wall, it's just not as nice and colourful and not as big. So you can see at the top it has one, so that is one whole, okay? And then you can see that each layer is broken up. So the second layer of that whole is broken up into two. They're in two equal parts, so therefore there's a half and a half. The next one is broken up into three equal parts, therefore it's split into thirds. And then the next one is broken into four equal parts, therefore there's quarters, okay? And it shows you that actually two halves make up a whole, three thirds make up a whole, 1, 2, 3, 4 quarters make up a whole, okay? It shows you what the equivalent is to a whole, but it also can show you the equivalent to other fractions. So, for example, here you can see a half, and you can see that that is the same size shape as 2 quarters. So it takes up the same amount of size, sorry, in this shape, the whole shape. Okay, so hopefully that I went through it there a bit better and you understand it a bit more now. If you're still in a pickle with it, don't worry too much because we will be going back over it at some point in the topic anyway, so don't worry too much. So moving on to today's learning then, your starter for today is on perimeter and area. So I would like you to find out the perimeter and the area of this shape. And the squares are 1 centimeter squares, okay? So don't, it's not to scale, so don't worry too much about actually measuring it, but just count the perimeter, so count around all the sides. Don't forget these little pesky sides here. Have a go at that and then work out the perimeter and we'll go through the answers together. So pause the video, have a go at working out the perimeter and the area for me. Okay, hopefully you managed to have a go at that. So your perimeter should have been 18 centimeters because what I did, you might not have done it like this, you might have just counted around the edge, but I wrote down how long each side was and then counted them all together. So I got 18 centimeters. Remember to have the centimeters on the end. And then the area is 15. So I just counted all the squares. And as I went along, I put a dot in each one so I knew which ones I had already counted. Hopefully that makes sense. If you do want to revisit anything on area or perimeter, the video should still be on YouTube. So you can always go back and have a look at those. Okay, moving on to today's learning then, we're carrying on with equivalent fractions. So what I would like you to do is have a look at these star words. Are there any that you're not sure about? So think about numerator and denominator. Can you remember what those are? What does equivalent mean? So we talked about them yesterday, sorry, because they're the same as yesterday. Can you have a think about what the numerator and denominator is and what equivalent means? Okay, hopefully you had a quick think about those. So remember the numerator is the number on the top of the fraction. Denominator is the number on the bottom. Remember the D for down. So it's down below at the bottom of the fraction. And equivalent means the same. So if there are two fractions which have the same value, then they are equivalent. They're the same. So I want you to have a look at, that should say these fractions because there's two. So we have a half and we have 2 quarters. How are these equivalent fractions? So looking at these, how are they equivalent? What's similar about them? Have a quick think. You might want to pause the video and see how they're equivalent and see if you can work out how you would get 1/2 to 2 quarters. So what you could do is look at this, and you know that to get from 2 to 4, you times it by 2. And remember, whatever you do to the numerator or the denominator, you've got to do to the other one. So if you do something to the bottom, you need to do it to the top. If you do something to the top, you need to do it to the bottom. So if you times the bottom number, the denominator, by 2, that means you've got to times the top number by 2. And 1 times 2 is 2. Therefore, that is equivalent because if you times both of these by the same number, it's going to be equivalent. You could times it by any number and it would still be equivalent as long as you times them both by that same number, okay? Because if you had, let's do 1/2 again, and you times that by 3. Remember that you have to do the same to the bottom as you do to the top. 1 times 3 is 3, 2 times 3 is 6. So 3 6 is equivalent to 1/2 as well. So now I want you to have a go then. Try finding equivalent fraction for this. If you're not sure, stay with me and we'll go for it together. If you want to have a go at working out your own ones, then do it now. So I'm going to go nice and simple. I'm just going to times it by 2 to find an equivalent fraction. So I'm going to times the top by 2, the numerator, and the denominator by 2, because remember you always times them by the same number. So 1 times 2 is 2, 4 times 2 is 8. Therefore, 1/4 is equivalent to 2/8 because I've just times it by 2. I could have times it by 3, I could have times it by 4, I could have times it by 156, and I would still got an equivalent fraction. Okay, so there's no wrong or right answer for this really, as long as it is still equivalent and you times both of these numbers by the same number. Okay. So if you did manage to have a go at this on your own, I can't really mark it for you or tell you what the right answer is because there are endless answers. So just make sure that you times both of your numerator and denominator by the same number. So now it's time for you to have some more practice on this. So what I want you to do is find 3 equivalent fractions for each of these fractions. So if you're feeling quite confident, start on fluency 2. If you're not feeling very confident, start on fluency 1. And if you're really in a pickle, stay with me and we'll go through the first one together. If you want to have a go, but you're not too sure what to do, then just times each fraction by 2, 3, and 4. Okay, you don't have to times it by big numbers. If you want to, you can, but if you want to stick with these simple numbers, then do that. So, for example, 1/2, you would just times 1/2 by 2 for your first one, then 1/2 by 3 for your second one, and then 1/2 by 4 for your fourth one. Okay, so it's third one, sorry. So it's quite straightforward. But if you're really in a pickle, then stay with me and we'll go through the first one together. The rest of you can pause it now. Give yourself about 5-10 minutes to have a go at either fluency 1, 2, or 3. So for those of you who are in a bit of a pickle, that's fine. It is quite a tricky thing to get the hang of. So we're going to do 1/2. I'm going to write it a bit differently because I don't like it like that. So we have 1/2. We're going to times that by 2. So you times the top number by 2 and then the bottom number by 2. And that will give you 1 times 2 is 2, 2 times 2 is 4. Therefore, 2/4 is equivalent to 1/2. Let's do it for times in by 3. Didn't mean to write a 3 though. So times the numerator by 3 and times the denominator by 3. So 1 times 3 is 3, 2 times 3 is 6. Therefore, 1/2 is equivalent to 3/6. And if you wanted to, you could use a fraction wall to prove these as well, okay? Just because we're looking at a different method doesn't mean it won't show it on the fraction wall. Now I want you to have a go at times them by 4. So use the same method, but times it by 4. So times 1 by 4 and then 2, and then just put your fraction together, okay? The rest of you, you can carry on and have a go at the rest of them. So give yourself about 5-10 minutes and see how you get on. Okay, hopefully you managed to have a good go at those questions. I can't really go through the answers with those because like the other one, there are endless answers because you could have times it by any number. So as long as you have times both the numerator and the denominator by the same number, then you should have an equivalent fraction. Let's move on then to this question. Okay, this is our developed learning. So look at the fraction. We have 2 denominators here. We have 20 and we have 10. So what we need to do is think about the kind of relation with 10 and 20. And I'm actually going to swap them around because it's more confusing having it that way. Oh, I can't. Let's do this. There we go. So how do I go from 10 to 20? What number do I times it by? Have a quick think. What do you times 10 by to get 20? It is 2. So if you know you times the bottom, the denominator by 2 to get 20, what are you going to times the top number by, the numerator? By 2. Because whatever you do to the bottom number, you need to do to the top. Now, we don't have a numerator, so therefore we can put in whatever numerator we want as long as it's less than 10. So I could put in 3, and then 3 times 2 is 6. And there we go. I could have put in 8. 8 times 2 is 16. I could have put in 1. 1 times 2 is 2. And it's the same process, okay? Whatever you put in here, you just have to make sure you times it by 2 because the denominator's been times by 2. All right? Now, if you feel confident, have a go at this one on your own. If you're not too sure, then we'll go through it together. So this one, again, I'm going to move it around because I find it's easier if the smaller number is at the first fraction we look at. So we have two numerators here. Now we have 5 and we have 10. So I need you to have a look at them and look at what the relationship is here. So what do you times by 5 to get to 10? So again, it is 2. So therefore, the denominator needs to be times by 2. And again, we haven't been given any denominators. So we just have to put our own one in and then times it by 2. So we need to make sure it's a number bigger than 5 because it's the denominator. It needs to be at the moment we're looking at fractions where the top number is lower than the bottom number. So we could do 6. 6 times 2 is 12. We could do 7. And have a think about what the denominator would be on the other number. 7 times 2, 14. And you could go on. You could do any number here. And as long as you times it by 2, then it's equivalent. Okay? So hopefully that makes a bit more sense. It's time for you to have a go now. I know I've been waffling on for quite a lot today. So I want you to have a go at these. If you're not very confident, have a go at group 1. I think you do need to do a bit of shading, but you can draw the shapes in your book or just write the equivalent fraction for me. It's up to you. I don't mind too much. Or if you have a printer, print it off. That would be great. But don't worry if you haven't. So group 1, if you're starting now, then pause the video so you can start on this one. Remember to spend about 20 minutes or so doing this, no longer, because I don't want you to spend too long on it. This is the second question for group 1, so you might want to pause the video to have a look at this one. And then this is group 2. And this is group 2 as well. And the challenge, if you go on to the challenge, okay? So pause the video, have a go at them, give yourself about 20 minutes, and then come back and we'll go through the answers. Okay, it is time for answers. Hopefully you managed to do a few of those questions. Don't make sure you have done at least a couple and you spent a good 15-20 minutes on them because it's really important you do some of the work just to consolidate your learning. Let's have a look at group 1. So use the shape to find equivalent fractions. So we can see here we've got 1 out of 2, therefore it's a half, and here we've got 6, so therefore our denominator 6, but we have 1, 2, 3 shaded, and you can see in the shape that that is the same amount shaded as that. Now this one, you have 1, 2, 3, 4 out of 5, and I'm just going to shade them in so it looks the same as the other one. And we've got 10 boxes all together, and 1, 2, 3, 4, 5, 6, 7, 8 shaded. So therefore it's 8/10. This one, you can see that this box is, so 1 out of the 4 is shaded. This is split into 8ths, so therefore the denominator is 8 because there's 8 boxes. And there's 2 shaded, so therefore it's 2/8. Now this one is a bit of a tricky one because they haven't actually given you a shape to find, they've just given you a blank. So you could have done your own. What I'm just going to do is times this by 2 to find an equivalent fraction. So 10 15ths, that was meant to be. You times both by 2. Because if you times it by 2, it should be quite simple. 10 times 2 is 20. 15 times 2 is 30. And you could have drawn that if you wanted to, but I'm not going to because it will take quite a while. So your answer should be 20/30ths. But you might have got something different if you chose to times it by a different number. So the second part of group 1, then you had to fill in the missing numbers. So what you had to do is look at what happened to the either denominator or the numerator. So here I can see the denominator's been times by 4. So therefore the top one had to be times by 4. 1 times 4 is 4. This one, to get from 3 to 15, it's been times by 5. Therefore 4 times 5 is 20. This one, 3 to get to 9, been times by 3. So 5 times 3 is 15. To get from 6 to 24, that has been times by 4. So 1 times 4 is 4. This one is gone the opposite way. So you need to do the reverse for this one. So you should have done 21 divide by 7. So what do you have to divide by 21 to get 7? So how many 7s are in 21 basically? And that is 3. So if you do 21 divided by 3, you'd get 7. Therefore, 6 divided by 3 is 2. That's quite a complicated way of doing it. What you could have done is just put them the other way around. So you could have done 7 there and times it by 3. So I don't know why I did divide, sorry, that's just really confusing. You could have times it by 3 to get the bottom one, but then the top one you'd have had to divide it by 3 to work it out. Okay, that's a bit of a tricky one, but we will go into a bit more detail on that on Monday's lesson. Been watching too many Netflix episodes clearly. The next one then, 20/24. So you can have done whatever one you wanted for this, so I'm not going to fill it in. What I would have suggested though is just halving it. You could divide it by 2, which would have given you 10/12, and then divide that by 2 again, which would have given you 5/6. All right. Hopefully that makes sense. You could have also doubled it or times it by whatever number you want. So that's why I'm not filling out, because there'd be lots of answers. Group 2 then. So these are more challenging questions. You had to do more problem solving work for these ones. So I'll do the matching ones up first. So draw lines to connect the equivalent fractions. So I'm going to start nice and easy. I'm going to start on 10/20ths. So I'm looking for a number on the other denominators that's in the 20 times table. Now I can already see 20, however that's been matched up. So my eyes go straight to 60. Now 60 is in the 20 times table. If you times 20 by 3, you'd get 60. However, if you times 10 by 3, you will not get 55, therefore it's not this one. Now, I'm looking now at this one. Now, we know if you divide 20 by 10, you'd get 2. And if you divide 10 by 10 by 10, sorry, you'd get 1. Therefore, it should go with this one because it's divided by 10. Okay, I'll use another pen for the next one. I will go to this one next, 11/12. So I need the number in the 12 times table for this one. So it could be 6, I guess, because half of 12 is 6. So I guess it doesn't need to be in the 12 times table. It just needs to be 12 needs to be in the same times table as another number. So 6 and 12 in the same times table in the 3s. So 12 divided by 2 would be 6. And then 11 divided by 2 would not be 4. So 27, not in the 12 times table. 60, it could be. So we could do 12 times 5 to get to 60. 11 times 5 is 55. Therefore, that matches with that because you times each one by 5. Let's go on to 2/3. So 2/3, have a look at that one. Now, 3 times 2 to get to 6. 2 times 2 to get to 4. Therefore, it's that one. You times this one by 2, and you'll get this. 3 times 2 is 6, and 2 times 2 is 4. It's quite a lot to do on this one. I know it's tricky, but it's just a bit of trial and error. You just have to see if it works, and if it doesn't, move on. Okay, and that's just what I'm doing. I'm just explaining my workings out, which are going on in my head right now. 5, 6. So 6 could go with this one because 6 times 2 is 12, and then 5 times 2 is 10. Therefore, it goes with that one. And then that must mean 2/9 goes with 6/27. Let's just work out. So 9 times 3 is 27. 2 times 3 is 6. Therefore, that's correct. And then this one. So you can see here that to get from 5 to 45, you have to times by 9. So whatever number you put here has to be times by 9, and it has to be less than 5 for the fractions that we're doing. So you could have done 4. 4 times 9 is 36. Then 3. 3 times 9 is 27. And then 2. 2 times 9 is 18. Okay, so I just spotted straight away what you do to 5 to get 45, And then I just did the same for the top. So 4 times 9 is 36, 3 times 9 is 27, 2 times 9 is 18. With this one then, you times 6 by 3 to get 18. So whatever you put here needs to be times by 3 to get this. So you could do 7, because it needs to be a number bigger than 6. So 7 times 3 is 21. 8 times 3 is 24. And then 9. You could have done any numbers, to be honest. These are just the ones I've chosen because I think it's easier that way. 9 times 3 would be 27. Okay, hopefully that made sense. There is a lot to go through that, and I know it is quite tricky, but we will be looking at it again on Monday. And then this one again, I can't go through this one with you because there are lots of answers you could have got. But it's important to note that this is a whole. If you have 10 tenths, that is going to be one whole. On the fraction wall, if I go back to yesterday's fraction wall, you can see at the bottom, if you count 10 tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is the same as one whole. Okay, it takes up the whole shape, so therefore it is one whole. Just an important thing to note, really. And then the last one, the challenge. This one was quite a tricky one. So don't worry if you didn't get it. It is really tricky. I kind of just put it in there just to test you a bit, but don't worry if you didn't get it right. So what you had to do was work out how they're equivalent. So you had to find something called a common denominator. So you had to try and make these the same denominator. And they're different fractions, so you can times them both by different numbers. So I tried it took me a while, I won't lie, but I worked out that if I times 12 20ths by 3, I would get 36 60ths. I've just times it by 3, so I've done 12 times 3 is 36, 20 times 3 is 60. Now, you might think, how does she know it was times by 3? You times it by 3. I didn't know straight away. It was trial and error, so I timed it by 2, and then I timed by 3. So I didn't know straight away. It was just me giving it a go. And then 9/15, basically, I want 15 to become 60 because I want the same denominator as this. Because if these are the same, then we just need this same denominator to compare them. So 9/15, if you times that by 4, you get 36 because 9 times 4 is 36. And 15 times 4, you might need to use your column method to work this out. 4 times 5 is 20. 4 times 1 is 4. Add 2 is 6. So 36 60ths. And now we have the same denominator, so we can compare them. And you can see that they are the same. Therefore, they're equivalent. That is a really tricky and quite a nasty question. So don't worry if you didn't get it right. It is tricky. I hopefully explained it a bit better there. But like I said, we'll be revisiting this. Fractions are tricky, and that's why we're going through them. And I'm going through all the answers with you to try and help you. But don't worry, we're going to do a lot more work on it. And next week, we'll be looking at more equivalent fractions. So we'll go through it again. All right. Any problems or any questions, please send me an email. And I know this is a very long video, so hopefully I didn't waffle on too much, and I hope you didn't get too bored. Have a great weekend, and I will speak to you all next week.